A warm welcome to this platform. So in this video, let us discuss organic chemistry. The first thing, let us define what organic chemistry is. So organic chemistry is simply the study of carbon compounds, excluding N oxide and carbonate. So we can say is the study of So it's simply the study of carbon compound except oxides and carbonate. That is how we define organic chemistry. Having defined organic chemistry, let us look at the terms before we go further in our study of organic chemistry or in our discussion. Let us look at the terms used under organic chemistry. So we're going to say terms under organic chemistry. What are some of the terms that we need to know as we go on studying this topic? Okay, so some of the terms that we can look at: one, organic compounds. So the first term we'll look at organic. What are organic compounds? What are organic compounds? Okay, so organic compounds are simply compounds which contain carbon but exclude N oxides. So you can say are compounds which contain carbon excluding or except oxides and carbonates. So that is how we can define organic compounds. So organic compounds are simply compounds which contain carbon but exclude any oxide or carbonates. Then the other term that we can look at is a second term under this one. We'll look at hydrocarbons. Hydrocarbons. So as the name suggests, hydrocarbons, hydrogen and carbon. So these are simply compounds which contain carbon and hydrogen only. So we can say are compounds which contain hydrogen and carbon only. So that is how we can define this one. The next term that we can look at is homologous series. Now, before we go further, let me just give examples of hydrocarbons. So examples of compounds that contain carbon and hydrogen only. The families that we are going to look at, we have the alkanes, then we have the alkynes or alkenes, then we have the alkynes, although we are not going to focus on the alkynes, but we focus only on alkenes and alkanes. Okay, so these are examples that or examples of hydrocarbons. Another term that we look at, which is the third term in this case, is the homologous series. Homologous series. Now, what is a homologous series? So it's simply the family of similar organic compounds. So you can say a homologous series is a family of similar organic compounds. These are what we call homologous series. Now, looking at homologous series, we should be able to know, or we should, under this one, we are going to go further to look at characteristics. Okay, characteristics of these compounds that are found in the same homologous series. So we can say characteristics of the homologous series. Characteristics of the homologous series. What do compounds that are found in the same family have in common? So one of them is that they have similar chemical properties. They have similar chemical properties. Now, when you talk of chemical properties, we are just looking at the way they react. So, those that are found in the same family, in terms of reaction, they react the same. But here we should take note that there is a gradual change in terms of their physical properties. So, in terms of their physical properties, although they have similar chemical properties, in terms of their physical properties, they show a gradual change in their physical properties. And this is due to the increase in number of carbons. So, take note of that. Another characteristic that we can look at is that they conform to the same general molecular formula. So you can say they conform to the same general molecular formula. So that is another characteristic. So they come from the same formula, which is called the general molecular formula. We're going to see what that means soon. So the other one that we can look at is members from the same family have similar methods of preparation. So we can say they have similar methods of preparation in their physical properties. So when you talk of properties or physical properties, we can talk of density, melting point, boiling point. So that is what we can refer to in terms of physical properties. So you know that these are made up of carbon compounds. So as the carbon chain or the chain increases, also their boiling and melting point increases. We are going to see this where we are going. I'll get to re-emphasize on this point. Otherwise, let us look at now the families that we are going to study as we go on. So under this one, the families that we are going to look at, alkanes. We are going to look at alkenes. So these are the ones that we are going to study. Then we are going to look at alkanos or alcohol. So alkanos or alcohols. Then we are going to look at carboxylic acid or alkanoics. So carboxylic acids. Then we are going to look at esters. Okay. So these are the ones that we are going to look at. Now, just to give their general formula just at this point. So the general formula, we said families or members from the same family, they conform to the same general molecular formula. Now, in terms of their molecular formula, what is the molecular formula of alkanes? So for alkanes, CN2N plus 2. Then for alkenes is CnH2N. So these you need to know them. Then for alcohol is CnH2N plus 1. Then of course OH. Then for carboxylic is CnH2N plus 1 COOH. Then of course esters. For esters is H2N plus 1. Then we have COO. Then we have CMHM plus 1. So under this one, what does N represent? So N represent number of carbons. So N represent number of carbons. Even M here under the ester ones represent the number of carbons. So number of carbons. So make sure that you take note of these. So these are the general molecular formulas that we have for the families. So for alkanes is this one. All of them are made from that. That is compounds under alkanes all come from that. Then alkenes come from that. Alcohol come from that. Then we have carboxylic come from that. Then esters all come from that. So these are very important to know them where exams are concerned. Okay? So a functional group is just a group which determines the chemical properties of compounds. So under this one, the families we said we are going to look at alkanes. Now, alkanes do not have a functional group, okay? So these do not have the functional group. But when you talk of this, the other one, such as alkenes, so alkenes, the functional group, there's a double bond between carbon. So in other words, the functional group of alkenes is the double bond. So the double bond is the functional group. Then we have alcohols. What is the functional group of alcohol? So when you look at alcohol, each alcohol has the OH. That is how you know that this is an alcohol. So this is called a hydroxyl group. Okay? So this is called a hydroxyl group. So in other words, alcohol has a hydroxyl group as the functional group. Okay? Then when you talk of carboxylic acids or alkanoics, okay, so carboxylic acids. Now, if you look at carboxylic acid, what they have as a functional group is COOH, otherwise which can be drawn as C, double bond there. Then we have, of course, OH. So this is the functional group. Then, of course, this one can be presented as such. Okay, there's a bond between here. Okay. Then, of course, the other one, which are esters. What is the functional group of esters? So the functional group, of esters is just this. This is the functional group of what? Of esters. And of course, it's a ester functional group. All right, so that is another term that we need to know under this one. All right, now let us go to the other thing that we need to know, and that is the nomenclature. Nomenclature. What is the nomenclature? So is that simply the standardized way of naming compound? So it's the standardized, okay, standardized way of naming compounds. Okay, standardized way of naming what? Compounds. And it takes into account, so we can say it takes into account two things. One, the prefix, then two, the suffix. Now, if you want to name organic compounds, you are going to consider the prefix and the suffix. So what is the prefix? So the prefix is just found at the beginning of the name. Okay, so at the beginning of the name, you are going to have the starting part, which you call the prefix. Then the suffix is just the ending part. Okay, the suffix is just the ending part of the name. So nomenclature is the standardized way of naming organic compounds. And of course, it takes into account the prefix and the suffix. Okay, we said the prefix, what is found at the beginning of the name. And this is determined by the number of carbon in the compound. By the suffix, we are looking at the ending part of the name. And this comes from the family where this compound is coming from. Okay, so let us look at the prefix. So, for the prefix, examples of the prefix, so we are saying depends on the number of carbons. So let us start with the carbon 1. So for carbon 1 here, so this first part is number of carbons. Okay, so carbon 1, what is the prefix? So the prefix is meth. Carbon 2 is eth. Carbon 3 is prop. Carbon 4 is but. Carbon 5 is pent. Carbon 6 is hex. Carbon 7 is hept. Carbon 8 is oct. Carbon 9 is non. 10 carbon is dec. So these are the prefix. We are going to go up to 10. These are the prefix that you put in front of the name of a compound. In the case it has these, depending with the number of carbons, I mean. So if it has 1 carbon, the prefix or the beginning part of the name is meth. Then if it has 2, eth, 3, prop, 4, but, 5, pent, 6, hex, 7, hept, 8, oct, 9, non, 10, dec. I guess we are together up to this point. So this is for the prefix. Then if we are to look at the suffix, let me just put it here so that we can even look at maybe examples. If we are to look at the suffix, the suffix we said comes from the what? The family or the homologous series where it belongs. So the families that we are going to look at, we said we are going to look at alkanes. So if it's coming from alkanes, or if you are dealing with an alkane with 1 carbon or whatever carbon, the end part of the name is en. Okay, this to mean that the first carbon or the carbon with the compound under alkanes with 1 carbon is called methane. So we just add N at the end. I guess you've gotten what I'm saying. So what I'm saying is that under alkanes, if this is a family, the end part of the name, the suffix, you have the prefix. If it has 1 carbon, it's a meth. If it has 2 carbon, it's a eth. If it has 3, prop, but, pent, and if it has 10, it's a dec. But the end part of the name, which is the suffix, you add this to make the name of a compound under that family. So I said, in the case of alkanes, the first one in the series that has 1 carbon is called a methane. Then, of course, the second one is going to be the ethane. The third one is going to be the what? Propane. The fourth one is going to be a butane. The fifth one is going to be the pentane. Number 6 is going to be hexane. The number 7 is going to be heptane. Then number 8 is going to be octane. 9 is going to be a nonane. And of course, a 10 is going to be a decane. I guess this makes sense, or I guess this you are relating with this. So if we are to deal with a family that is alkanes, that is what we can say. But what about alkenes? What is the end part in the case we are dealing with alkenes? So in the case we are dealing with alkenes, the name ends with en. So going back now, in this case, there's no alkane with 1 carbon. Okay, I mean there's no alkene with 1 carbon, so there's no way 1 carbon would form. Alkenes start from 2 carbon. So in this case, the first one will be ethene, then will be propene, then butene, then pentene, then hexene, then heptene, then we have octene, then we have nonene, then we have decene. So this is how it becomes. Okay, I guess we are together up to this point. Let us look at another one, which is alcohol. What is the end part or the suffix of alcohol? So the end part is ano. Okay, so the end part is what? Is ano. Now let us look at how the names will be. So if you have an alcohol with the 1 carbon, if you have an alcohol with 1 carbon, it will be a methanol. 2 carbon, it will be ethanol. 2 carbon, it will be ethanol. 3 carbon, it will be propanol, butanol, pentanol, hexanol, heptanol, octanol, nonanol. Then we have decanol. So this is how alcohol names are formed. I guess you've gotten something up to this point. Up to the next one, which is carboxylics or carboxylic acid or acids. What is the end part? The end part is the anoic. Anoic. So now let us look at, and by the way, the alcohol, the first one has 0 carbon. So you're going to look at that as we get to look at each family. At the moment, we are just focusing on the nomenclature, how they are named. So now look at this one. So here, the first one here, if in the case of carboxylic, the first one is going to be methanoic. The second one is going to be what? Ethanoic. then we have propanoic, then we have butanoic, then we have pentanoic, then we have hexanoic, then we have heptanoic, then we have octanoic, then we have nonanoic, then we have decanoic. So these are carboxylic. Okay, these are carboxylic. All right, up to the next one, which is the esters. In the case of esters, the end part of the name is anoyet. Anoyet. So in the case of the one with one carbon, and by the way, esters are named because esters are formed when the acid react with alcohol, but just the part of the name, how you pronounce them. In the case, it is formed with an acid which has one carbon, it become methanoyate. Okay, methanoyate, which means, methanoyate, which means this one will become ethanoyate. This one will become propanoyate. Then will become butanoyate, part of a name. But as we go on, we are going to look at how these are named. The names, the first part of the name come from the alcohol, the second part from the acid. But otherwise, I guess you've gotten the general thing here. Okay, so this is the basic introduction to organic chemistry that you need to know. So please, if you've enjoyed the lesson up to this point, do not forget to subscribe, share to as many friend, family, so that they can also learn. And don't forget to follow me also on other platforms with the same name on Facebook, on TikTok, on YouTube. All right, so we can continue. Now we look at the families one by one. So the families that we have are 1, alkanes, alcohol, carboxylic, esters, and at the end of the topic, we should be able to look at the macromolecules. So at the moment, we start with the first family, which are alkanes. All right, so what are alkanes? What are alkanes as the homologous series? So we know that alkanes, what I can say about alkanes, we say alkanes are carbon or are hydrocarbon. Alkanes are hydrocarbons with general formula CnH2n plus 2. This is something that you have to know. So alkanes are hydrocarbons, which means they contain only hydrogen and carbon, with a general molecular formula or general formula of Cn2n plus 2. Okay. Then the other one that you should know is that they are saturated. Okay. They are saturated. Now, what does it mean they are saturated? These are saturated hydrocarbon. And by the way, alkanes do not have the functional group. So they are saturated hydrocarbons because they contain a carbon to carbon, okay, contain carbon to carbon single bond. So they contain a carbon to carbon single bond, and that is the reason why they are saturated. Now at this point, it's very important to understand a thing as well, such as how many bonds does a carbon form? How many bonds does a carbon form? So a carbon forms 4 bonds. So around a carbon, there should be, there's a room for 4 bonds. So in alkanes, you find that all 4 bonds are occupied by hydrogen, since we say these are hydrocarbons. So there's no room for chemical attack by other atoms, and hence we are saying they are saturated. And in addition to that, as we look at these, you are going to understand that these are not reactive, they are non-reactive. They only undergo a certain reaction, of course, at a certain condition, or there are conditions at which they react. So alkanes are hydrocarbons with a general formula that you are seeing there, CnH2n plus 2. They are saturated hydrocarbon because they contain a carbon-to-carbon single bond. And of course, we are saying a carbon form 4 bonds. So in alkanes, all the 4 bonds are occupied. We know for sure where we are coming from, that in this case, N in this formula is, N in the general formula is just simply number of carbons. Okay, now let us look at the first 5 alkanes. The first 5 alkanes, I know where we are coming from. We already looked at them, but we can just do a quick. So the first 5, which means the one with 1 carbon, the first one with 1 carbon up to carbon number 5. So now, number 1 is the one with 1 carbon. So to come up with the molecular formula, by the way, we are going to focus on the molecular formula and the structure or structural formula, okay, and of course the name. So that is what we are going to focus on as we look at this. So number of carbons here, let me just write on top as number of carbons, okay, so that we generalize it like this. Okay, so number of carbons, the first one, we'll look at the one with 1 carbon. Now 1 carbon, the name is methane. You know where we are coming from. Meth for 1 carbon, N coming from the family. So now, the molecular formula, we put a 1 where there's N, so it's going to be C. Then 2 multiplied by 1 is simply 2 plus 1, that is 4. So the first one is CH4. That is called methane. Now, in terms of structure, we want to show the bonds, how they are bonded to a carbon. Since there's only 1 carbon, so you have a carbon at the center, hydrogen at the end, hydrogen. So make sure that you align the bonds nicely, okay? So a line is used to present bonds. So if you just write a hydrogen suspended without bonds, that is totally wrong. So that is how you draw the first one. Let us have a look at the second one. So the second one with 2 carbons is called ethane. As you know where we are coming from, we said the prefix for the one with 2 carbon is eth, and since we are dealing with alkanes, it is going to be ethane. All right, so the name is ethane. Now for ethane, how do you come up with the molecular formula? So just insert a 2 there, so it's going to be C2, then H2N, 2 multiplied by 2, 4 plus 2, that is 6. Okay, so this is the molecular formula. Then of course the structure here, carbon is always at the center, and they start by putting up the carbon chain. So in other words, here we have 2 carbons joined with a single bond. So around each carbon, you know that each carbon is bonded to 4. Around each carbon, surrounded by the hydrogen. Remember, these are hydrocarbons. And don't forget to take into account the number of carbon and of course hydrogen. As you can see, hydrogens are 6. So 1, 2, 3, 4, 5, 6. Then carbon 2. Don't forget to put a bond here. And that is the reason why we say start by putting up the carbon chain first. All right. So since we are going up to 5, make sure that you go up to 3. I mean, you present the structure for 3, 4, and 5. Will you be able to draw these structures? So please go on, write the name, their molecular formula, and structural formula. That is your work. All right. Okay, let us proceed to the other things under this one. So, what are the physical properties of alkanes? So the other part that we need to look at under alkanes are their physical properties. What are the physical properties of alkanes? One physical properties of alkane is that the first 4, it is believed, the first 4 are gases. Okay, the first 4 are gases. The next 12, okay, the first 4 are gases. Next 12 are, so which means from carbon 4 up to 12 of them ahead are liquids. Then the next, or the rest, let me say the rest are waxes. Okay, so the first 4 are gases, next 12 are liquids, the rest are waxes. That is one of the physical properties. Okay. Then, of course, the other physical property is that down the group, or as the number of carbon chain increases, their melting point, boiling point, and density increases. So we can say their, or let me just say boiling point, melting point, and density increases with increase in the number of carbons. So in other words, as the carbon chain increases, you expect the melting point, the boiling point, and the densities increases. Now, these properties are important. You find questions where the compounds are listed, and now they ask you which one has the highest, let's say, boiling point. So you need to look at the one that has a lot of carbon. So take note of that. That is one of the questions that you find. Okay, so that is about the physical properties. Okay, now let us look at their chemical properties. Now, chemical properties, we said it is how they react, or when you hear of chemical properties in chemistry, think of the reaction. So these, from the start, we said they are non-reactive. So we can say alkanes are unreactive. So alkanes are generally unreactive. They are generally unreactive. What is the reason? Because the bonds between the carbon atoms, so they are generally unreactive. Alkanes, we are saying they are unreactive. So we are saying because the bonds between the bond between carbons are stable. Okay? The bonds between carbon are stable. And of course, the molecules lack specific site for chemical attack. Molecules lack specific site for chemical, go ahead and finish, attack. So alkanes are unreactive because the bonds between them are stable. So when you ask why are alkanes unreactive, because the bonds between carbon are stable, and of course the molecules lack specific site for chemical attack. So take note of that. All right, now despite this being unreactive, okay, despite alkanes being unreactive, they undergo specific reaction, of course, under specific or under a certain condition. So now we are going to look at the reactions that alkanes undergo. Okay, so we are saying we can say reactions alkanes undergo. I hope we are together up to this point. What are some of the reactions? So the first one is the combustion. Okay, combustion. Now, when you hear of combustion, just think of burning in presence of oxygen. So burning in presence of oxygen. In other words, alkanes can burn in oxygen to produce energy. Okay, so alkanes undergo combustion reaction, which means they can burn in oxygen and produce a lot of energy. The reaction is highly exothermic, very important, which means it releases a lot of energy. Now, under this one, as we talk of combustion, of course, there are different types of combustions. Okay, they undergo combustion, yes, but of course depends with the amount of oxygen present. So types of combustion, therefore, can be one, which we call complete combustion. Complete combustion. As the name suggests, complete combustion, which means burning completely. Now, under this one, we are saying this burns, or alkanes burn in a full supply of oxygen. So complete combustion, they are able to burn completely and of course produces carbon dioxide and water. So in other words, we are saying under this one, or we can say it occurs in plenty supply. So pay attention to the terms. They will not tell you we are dealing with you not be told you are dealing with complete combustion or incomplete combustion, which is the other one. But of course, through the terms that are used, plenty, you know that that is complete combustion. So the other term that might be used here under complete combustion is abundant or abundance. Then the other one, it can be full supply. So where you find plenty supply, full supply, or abundance of oxygen or air, just know that that is complete combustion. So complete combustion, it occurs in plenty supply, abundant supply, or full supply of oxygen. Okay? So let me just give an example here of an equation. So example, if you have methane, which is an alkane, react with, that is oxygen. In this case, what is given out? So very important to know the product. So in complete combustion, every time the product is water and carbon dioxide. That is in complete combustion. So this is the reaction of one of the member of alkanes, which is a methane, with oxygen to form carbon dioxide and water. This is called complete combustion. Now, if you look at this equation, it's not balanced, so we have to put a 2 in front here so that we have oxygen 4, then hydrogen 4, hydrogen 4, then you have 1 carbon, 1 carbon. So this is the balance equation for complete combustion. So one thing that you need to know that complete combustion occurs in plenty supply, full supply, or abundance of air, which is oxygen. And what is produced here, the product, carbon dioxide and the water, always. And at this point, I should say, all the compounds that we are going to look at, they undergo combustion, producing carbon dioxide and the water. That is in full supply. So one type of combustion is called complete combustion. Now, if there's limited amount of air or oxygen, we look at, the limited amount of air or oxygen, incomplete combustion occurs. So another type of combustion is called incomplete combustion. So the question is, what is incomplete combustion? So incomplete combustion is just where partially the compound partially burns, or they burn in limited supply of oxygen. In other words, here we can say incomplete combustion occurs in the terms that are used is limited supply. Then we can also say limited supply. You can say also short supply. Okay, so when you find such terms, limited supply, short supply of oxygen or air, just know that the one that is occurring is incomplete combustion. Like I said, you'll not be told that here you are dealing with incomplete combustion. Sometimes the question might come, what are the dangers of the organic compound, certain organic compound? Let's say this case is given is one of an alkane, or what is the dangers of burning alkanes in limited supply of oxygen? Such questions you might find them, so you should be aware. So let us look at, and I'll get to explain that. So for example here, if you have a reaction, let us use the second one, ethane. When it burns in oxygen, okay, in oxygen, what is produced under this one now, what you should know is that when a compound burns, an alkane burns in limited supply of air, what is produced is carbon monoxide and water. So coming back to the question, what are the dangers of burning these compound in limited supply of air? They produce carbon monoxide from, you know that carbon monoxide has high affinity for hemoglobin compared to oxygen. That is biology. So which means, or what it means is that it is transported instead of oxygen. And of course, when it gets to the brain or other parts of the body, it destroys the cells. Okay, so in other words, we can say it destroys the cells which needs oxygen. Instead they receive carbon monoxide, so it destroys the brain cells. In the case of the brain, that is what we can say. So these are the dangers. So when it gets to the blood, instead of oxygen, the cell are starved of oxygen and they tend to die. So in other words, it destroys the brain cell. If we are to focus on the brain cell, I guess you've gotten that. Okay, so this equation is not balanced. So for us to balance it, we just have to add a 5 here and also a 2 here, and we should be able to add a 4 there and another 6 there. I guess you know how to balance the equation, and please confirm that these are the correct numbers to balance the equation. If you don't know how to balance the equation, there is a video dedicated just on the part for writing chemical equations and balancing them. Should be able to find it on this platform if you are watching this video from YouTube. Okay, so that is incomplete combustion. But of course, in a very limited supply of air, alkanes react with oxygen to form simply carbon and water. So take note of that. We are looking at the reaction that alkanes undergo. So this was the first one, which is combustion. We said combustion, simply alkanes burns in presence of oxygen. And of course, they produce certain products depend with the amount of air present. So in the case of limited supply of air, what occurs is incomplete combustion. Okay, in the case of limited supply of air, what occurs in incomplete combustion, and what is produced is carbon monoxide and water. But in the full supply of oxygen or abundance of oxygen, alkanes undergo combustion or they burn to produce carbon dioxide and the water. I guess up to this point we are together. So we look at the second type of reaction under this one. So the second type of reaction that alkanes undergo is substitution. Okay, substitution. I bet you have an idea from the term substitution. So under this one, alkanes undergo substitution reaction with the halogens. So they undergo a substitution reaction with the halogens. Now, halogens, you just know that this is the special name for group 7 what? Elements. And these group 7 elements examples, we can talk of bromine, otherwise written as this. Then also we have choline. Okay, choline, which is also as this. So they undergo substitution. In other words, the group 7 element can substitute the hydrogen in the alkane and of course take its position. So what it means here, let me give an example of a methane, and I'll draw a structure to show that. So a methane is drawn as this, okay, okay, with 1 carbon with 4 hydrogen around. So now what happened is that if this was to react with a choline, let me put choline, and choline is represented, let us present it like this because it's a diatomic. So as you can see, there are 2 cholines there. So what happened here, the condition for this, or under in presence of UV light, in presence of UV light or high temperature, alkanes undergo, so you're saying O, high temperature, alkanes undergo substitution reaction. Okay, so what did happen here is that this choline here will substitute the hydrogen there, okay, and which means choline will go where there's hydrogen. So it's going to be hydrogen, carbon, hydrogen, hydrogen. 1 hydrogen is gone, replaced by choline, then plus hydrogen chloride. This hydrogen that is displaced react with that. So this is called chloromethane. Okay, it's no longer called methane, but instead it's called chloromethane. And of course, this is, this is methane. Then this is choline. So choline, when it reacts, becomes chloro. So that is the reason why it is chloromethane. And we are starting with chloromethane to prioritize choline. Okay, so that is a compound. That is what you're going to have from methane. That is chloromethane. Now, what about this chloromethane? This chloromethane, this time around, we react it again with the, again it react with chlorine in the presence of UV light. So take note of the conditions or high temperature. So the conditions are very important in the exams. You'll be asked what is the condition in which substitution reaction occur, or that type of reaction in the case you identified as a substitution reaction. So one of the condition is UV light. I mean, one of the condition, or the condition here, is UV light. So now, let's say it substitute this hydrogen this time around. So this time around you have two hydrogens substituted. So which means chlorine, hydrogen, hydrogen, then plus hydrogen chloride. So this one is the chloromethane. Of course, this is chlorine. Then this one is going to be dichloromethane because you have two chlorine now. Then this is hydrogen chloride anyway. So di comes from 2. So in other words, 2 chlorine. Then if this one was to react again, undergo substitution, this time around, chlorine is there, hydrogen there, hydrogen there. So plus chlorine. Okay, still UV light, and of course might be high temperature. So this substitute that one. This time around we are going to have 3 chlorines, okay, and 1 hydrogen chloride. So this one is the chloro or dichloromethane, we know, plus chlorine. So this one become now tri, okay, become now what? Trichloro, which means 3, trichloromethane. So this one become trichloromethane. If this trichloromethane, now this time around, all the hydrogens are substituted, become tetrachloromethane. So that is a substitution reaction. Now, it's not only chlorine, it can be a bromine. So in the case it was bromine, when it reacts becomes bromo. So it was going to be bromomethane. Then dibromo, this one was going to be dibromomethane. This one was going to be tribromo, okay, tribromomethane, okay, tribromomethane. Then was going to be tetrabromomethane. So you follow it in that way. So otherwise, that is substitution reaction. The other type of reaction alkanes undergo is called cracking. So the other type of reaction they undergo is called cracking. Okay, so we can say another one is cracking. Now the question is, what is cracking? What is cracking? So this is simply the breaking down of large, heavier, and more complex hydrocarbon molecule. So you're saying breaking down of large, heavier, and complex molecules into lighter molecules. And of course, these lighter molecules are the ones that are on demand. So cracking is simply the breaking down of larger, heavier, and complex molecules into lighter ones. Now, the cracking, the way it is done in 2 ways. Okay? It is done in 2 ways. So we can look at 2 types of cracking. So just from here, a lot of exam questions that you are going to find. So 2 types of cracking. We are saying cracking is just a breaking down of larger, heavier, and complex molecules into lighter molecules. But how is it done? So there are 2 types of cracking. The first one is the thermal cracking. So for thermal cracking, it involves the use of heat to break down large molecules into smaller ones. So thermocracking is just a breaking down of larger and complex, or larger or complex molecules into smaller ones using heat. So again, say breaking down of larger organic molecules into smaller ones. Using what? Using heat. Okay, so that is the thermocracking, using heat. Then the other one is called catalytic cracking. So for catalytic cracking, it involves using of minimal heat with an enzyme. I mean with a catalyst, not an enzyme, please. So involves use of small amount of heat and a catalyst. In this case, to break down large molecules into smaller ones. So catalytic cracking is as a breaking down of complex hydrocarbons using less heat and a catalyst. Now, here, very important to know examples of a catalyst. So, example of a catalyst here, because this part is very important. So, an example of a catalyst here, you can use aluminium oxide or silicon oxide. So, any of these can be used as a catalyst in this case. You know that a catalyst is just a chemical substance that that speed up rate of chemical reaction, and at the end of the reaction it remain unchanged. Very important to know that. So that is about cracking. So cracking is a breaking down of larger, heavier, and complex molecules into lighter ones. Two types of cracking. We have thermocracking, which involves use of heat to break down large organic molecules into smaller ones using heat. And of course, the catalytic cracking that involves the use of small amount of heat and of course a catalyst to break down large molecules into smaller ones. Now, the other question that you might find here in an exam is the reasons for cracking. So we look at reasons for cracking. What are the reasons for cracking? So one of the reasons for cracking is to meet demand for smaller molecules or compounds, to meet demand for smaller molecules, such as gasoline, okay? I mean, such as compounds such as petrol, diesel. These have small number of carbons. So these are on high demand as they are used in electro-based cars. Some of them are used in generators, some of them. So they are on demand, and therefore large molecules cannot be used for this purpose. They have to be broken down into smaller ones. So in other words, to meet demand for smaller molecules. That is the reason for cracking. Then the other one, you remember under non-metals that hydrogen can be made industrially by cracking. So to produce hydrogen used in Haber process to make ammonia. Not only in Haber process, but also in hardening of vegetable oil to produce margarine. So this hydrogen is produced by cracking. Then the other thing that we can look at, just to break down large molecules into smaller ones. Okay, that is the reason for what? For cracking. Okay, I hope we are together up to this point. There's no problem up to this point. Let us proceed. Okay, let us proceed. The other part that we can look at now is the part on isomers. So let us look at isomers. The question is, what are isomers? What are isomers? So isomers are just compounds which have the same molecular formula but different structure formula. We can say compounds with same molecular formula but different structure, okay, or structural formula. So this is what we call isomer. And of course, they are formed by the isomerism. So isomers are compounds which have the same molecular formula but different structural formulas, okay? Now, alkanes, since we are looking at alkanes, so for alkanes or isomers under alkanes, so alkanes with more than, which means alkanes with 4 carbons, and above exhibit isomerism, okay? Exhibit isomerism. In other words, they can be, or they can have, they can exist in 2 or more structures. So now, the one that we are going to look at in terms of isomers here, we look at the naming of, so we'll look at branched isomers, the one that involves branches, okay? Branching of the carbon compounds. Okay, since we are saying alkanes with 4 carbons and above exhibit, here, exhibit please, exhibit isomerism, okay? So we are going to start with the one with 4 carbon and look at how we can name these isomers and only form a branched isomer. So in this case, we look at the one with 4 carbon. What do you call it? Do you remember? What do you call it? Of course, butane. So butane is like this in terms of a structure. Okay, butane is like this. Now, this is the one that we know, but so this is called butane. But this butane can also be written as, let us say we put 3 carbons like that. Then of course, let us say we put carbon, the other carbon down here. But remember, each carbon is surrounded by hydrogens. Okay, so we draw the structure this way. We are saying isomers are compound with, okay, are compound with, or which have same molecular formula but different what? Structure formula. And I guess where we are coming from, we know what a molecular formula and a structure formula is. A structure formula is shown in terms of bonds. Molecular formula is just a condensed form. So now, let us look at this before we even name them. All right. So for the first one, let us count the number of carbons. How many are they? 1, 2, 3, 4. So if we were to write the molecular formula is C4. Then hydrogens 1, 2, 3, 4, 5, 6, 7. This is 7, 8, 9, 10. So H10. Okay. Let us count for this one. Number of carbons 1, 2, 3, 4. So number of carbons also C4. Then hydrogens 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So number of carbons, number of hydrogen also 10. You see, this is the molecular formula for this, and this is the molecular formula for this. Now, if you look at them, they all have C4H10. But in terms of the structure, they differ. And therefore here, these are what we call isomers. So butane has 2 isomers, this and this. Now, this one we know already is butane, but that is not the case of the second one. We need to name it. So now this is where we come to naming isomers. Okay? Now listen to this. Naming isomers, here we are going to look at the first thing. Rather, when you want to name isomers, make sure that you identify the chain that has a lot of carbons. In other words, the longest chain of carbons. That is the first part. So first part, identify longest or longer chain of what? Of carbon. Okay? So which one has a long chain of carbon? The one that has a lot of carbons. Now, we can consider it going this way and also going down, because these are the only chains. Here it is just one carbon. Okay, here is just one. Here is just one. But here in the middle there are two. Going this side there are three. So which one is a longer chain? Is it going this side or going down? If we are to count going this side, you find that there are how many? 3 of them. But going down, there are just 2. So the long chain here, it is this one that remains. So it has how many carbon? How many carbon? 3 carbon. So the long chain has 3 carbon. That is the first part. Now, the second part, look around what you have. What do you have? Do you have, ask yourself these questions. Do you have a branch? Do you have a functional group? Do you have a branch? Do you have a functional group? Okay. If you have a branch, you don't have any of the remaining, make sure that you prioritize the branch when assigning number of carbon or when counting. What it means is that after identifying the long chain, we are going to count this forward and backward. So counting forward, this is carbon number 1, this is carbon number 2, this is carbon number 3. Backward, this is carbon number 1, this is carbon number 2, this is carbon number 3. Now what we want, or why I'm doing so, is to have the counting that gives us the lower number in terms of carbon. So we want the one that gives us the lower number in terms of the position. So which one is going to give us the lower number? So when we count, in both cases, the branch is at 2. So what I mean the branch, after identifying the long chain, that the long chain is this one, whatever carbon is outside this line is a branch. So in other words, we have these are the branch. So the branch that we have is this one. So we want to give the lower number in terms of position of the branch. So in both cases, the branch is at carbon number 2. So we write 2, then dash. The next part is we name the branch. What is the name of the branch? Now, the branch, if it has one carbon, if it has one carbon with 3 hydrogens, is called the methyl. Okay, methyl. So the branch here is the methyl. But if it had two carbons, it was going to be ethyl. So in other words, from the prefix, we just add YL. If it has 3 carbon, it was going to be a propyl. It had 4, it was going to be a butyl, just a branch. So in this case, the branch is a what? Is the methyl. So first thing, we identify the long chain and make sure in the case of alkanes, we have a branched isomer. So we need to give the branch, we need to prioritize the branch, and by giving it the lower number. In this case, if we are to count forward, backward, you find that the branch is at carbon 2 either way. Now, what was going to happen if the branch was at carbon 1? If it was at carbon 1, we are going to follow the one that has a lower number, 2 and 1. So the correct counting was going to be the one that gives us a 1. And we are going to follow that and put the branch at 1. But in this case, in both cases, is 2, 2. So in this case, the branch is methyl. Now, what is the name of, after doing this, we look at the long chain now. What is the name of the alkane with 3 carbon? And the alkane with 3 carbon is called propane. So this branch is called 2-methylpropane. So we've named this successively. Okay, we've named this successively. So this is called 2-methylpropane. I guess that is okay. Let us have a look at maybe another example. This time around, we proceed to look at the one that has the 5 carbons, and that is a pentane. So this can be drawn as this 5 carbon, isn't it? Oh, let me start by drawing the original one. This is 5. So around, just know that they are hydrogens. Okay, around here they are hydrogens. Make sure that each carbon is bonded to 4. Okay, to 4 bonds. Around they are hydrogens. Remember, these are hydrocarbons. So this is the what? This is a pentane. Now, this pentane can also, so this is a pentane, can also be put like this, where we can put like this. So 4 carbons here, and let me just put, so around here I'll put hydrogens, 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 hydrogens. Here I'll put a carbon, of course, around it hydrogens, like this, hydrogens, 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 hydrogens. Okay, so now here, this is single bond, please. So now here, this is also has 5 carbons. Okay, so if I were to write the molecular formula, it would be C5. C5, how many hydrogens? Should be 12. So hydrogen 12. If I were to count this also, how many? C5, H12. So the molecular formula is the same, but of course the structure differs. So the first one is the pentane, but the other form of pentane, we need to write its name. How do you write its name? The first thing, identify the long chain, the one that has a lot of carbons. And if we were to look at this, wow, to that side, and of course coming down here. Coming down, there are only 2. If we were to follow this route, there are about how many carbons? 4. Then if we were to go down, there are about how many carbons? 1, 2. So the long chain is this one. Now, the moment we identify the long chain, whatever is outside is the branch. Or sometimes might not be 1, might be 2. So whatever is outside, considered as a branch. And of course, already this branch has 1 carbon, so it is a methyl. Let us take note of that. Now, if we are to count now, let us position now where the branch is. We said you count forward, backward. So 1, 2, 3, 4. So if I were to count going forward, the branch will be at carbon what? At carbon 3. But if I were to count backward, 1, 2, 3, 4, the carbon will be at what? The branch will be at carbon 2. So it will be at carbon 2. Now, which one would we follow now? One to prioritize or to give the lower number to the branch. So we are going to follow the one with a 2 instead of the one that we say what? 3. So here the name is going to be 2, not 3. Then the branch we said is a methyl. Now what remains now to complete the name is to look at what is the name of an alkane with 4 carbon. We follow the long chain. It's called a butane. So this is called 2-methyl-butane. That is the name. I guess we are progressing, or we are making progress. I guess we are making progress. Now, what about if it was this way? So the same pentane, let's say if we were to draw it this way, where we put the, or let me put the other one here, like that. So here we put hydrogen, hydrogen there, hydrogen there. Then of course here hydrogen, down here hydrogen, here hydrogen, here hydrogen, here hydrogen, there hydrogen, here hydrogen, here hydrogen, here hydrogen. Okay, if it was like this, what was going to be the name? Now look at this. Always we look at the long chain first. So if we are to look at this, it has the 3 carbons. This has only 2 carbons. This has only 2 carbons. And therefore, we follow the long chain. So after identifying the long chain now, we are going to count 1, 2, 3. Backward, 1, 2, 3. Now, whatever is outside, we said whatever is outside the long chain is considered as a what? A branch. So far we can see two branches, this and this. Okay? So now, here, the first branch is at 1, the second is at 2. So now, how we are going to write it, we write them 1, comma, 2, showing that one branch is at 1, the other one is at 2. Then dash, what is the name of the branch? Of course, this is called a what? A methyl branch. But since there are two, going to be dimethyl, then we name that way. So dimethyl. Then what is the name of an alkane with 3 carbons? It is called propane. So this is going to be 1, 2 dash dimethyl propane. 1, 2 dash dimethyl propane. So that is how it is going to be. So that is the name of this one. Okay, I guess you are progressing. So please, if you are watching up to this point, make sure that to comment, are you getting the lesson? Or are we progressing, going somewhere? Okay, so be able to comment, and of course, yeah, we appreciate just to have your feedback. All right. Now, maybe this time around, the same propane. So propane so far has 1, 2, 3. Then let me put up another way that you can write it like this. Okay, like this. Then the other one goes on top there. The other one comes down. So you can present it this way. Okay. Now, if it was presented this way, how are you going to name this? Remember, we said the first part, identify the long chain. Them, or let us number them. 1, 2, 3. So, going forward, the branch is at 2. Or branches at 2. What about backward? 1, 2, 3. Even coming backward, the branch is still at 2. So there are 2 branches there at 2. So we are going to write 2, 2 dash. What is the name of the branch? So the branch is called the methyl. And of course there are 2 branches. So it's going to be dimethyl. Now, since we are considering this one as a long chain, how many carbons does it have? 3. And what do we call the alkane with 3 carbons? It's a propane. So this is 2, 2 dimethyl propane. Okay, the other one was 2, 1, 2 dimethyl propane. So please, you cannot say 2, 1. You start with a smaller number. Okay, so that is how you name them. Otherwise, that is where we can end in terms of alkanes. I guess up to this point, you've gotten a thing. Okay, if you've gotten a thing, let us proceed to look at alkenes. So this chapter that we've started is for alkenes. Okay, alkenes. Now, what about alkenes? What do you need to know about alkenes? So unlike alkanes which are saturated, alkenes are unsaturated, which means they are reactive, and of course the double bond between them can break and allow more atoms to bond. So these are unsaturated hydrocarbons. Okay, unsaturated hydrocarbons. Why are they unsaturated? We can say they contain carbon to carbon what? They contain carbon to carbon double bond. Okay, they contain carbon to carbon double bond. So between 2 carbon of an alkane, or you find a compound with a double bond, just know that that is what? That is an alkane. This is the one that serves as a what? The functional group. In other words, it's the one that determines how they react. So the functional group of this is the double bond, in the case you're asked. Now, about this, we can say they conform. What is the general molecular formula? So conform, we can say they have a general molecular formula, okay? In case the word tend to be confusing. So they conform to the general molecular, okay, general molecular formula of CnH2n. As you can see, compared to alkanes, alkanes is CH2n plus a 2. So we have 2 hydrogen short in terms of alkenes. So very important to understand that. So we have no 2 here. That is the difference between alkanes and alkenes. And this makes them to have a double bond. So very important. So let us look at the first 5. First 5 alkenes. So the first 5 alkenes. Remember also where we are coming from about the prefix. So for the prefix, the one with 1 carbon is called the meth, 2 carbon is called eth, 3 prop, 4 but, 5 pent, 6 hex, hept, for 7, 8 oct, 9 non, and of course 10 dec. We go up to 10, but you can go further going up, but that is not necessary. Okay, so the first 5, don't forget the prefix. Now, since we are dealing with alkenes, the suffix is en. I think this part we have done it already at some point. So just like alkanes, also here we look at number of carbons, the first part, then of course name, we put name here, then the other part we put molecular formula, then we put general molecular formula. Okay, general molecular formula. So now, number of carbons, we said alkenes start from 2. There's no alkene with 1 carbon, so there's no methene. Only start with 2. And this is very important. Sometimes they'll ask you, give the name or draw the structure of an alkene that is third in the series. So that is third in the series is not propene, but instead is butene. Okay? Because the first one is what? Ethene. I guess you've gotten my point here. So for 2 carbons, you are just going to replace a 2 in this formula. So it's going to be, in terms of molecular formula, it's going to be C2. Then 2 multiplied by 2 is just 4. So it's just double the number of carbon to find the number of hydrogen. And this is how you'll be able to identify them. Because sometimes you'll be given the molecular formula. Now they ask, is that an alkene or alkane? So to identify an alkene easily, you just look at the number of carbons, and to look at the number of hydrogen is just a double the number of what? The number of carbons. I guess it's making sense. So the name of this one is called ethene. The name of this one is what? Ethene. Okay. Then the molecular, the structure formula. So please here it's supposed to be the structure formula, not the general molecular formula, but the structure formula. So in terms of structure, we said you draw shore bonds. So how many carbons are there? 2. But of course, you know that between 2 carbons, there should be a double bond. The fact that there's a double bond, carbon is already bonded to 2, or each carbon is already bonded to 2. So it only needs 2 bonds remaining, and that is where you put hydrogens. Okay, so hydrogens there, hydrogen there, and of course hydrogen there. I guess you've gotten something up to this point. So this is the structure of ethene. The other one that we can look at is the one with 3 carbons. Now 3 carbons, if we are to replace 3 in this formula, you are going to find, in terms of molecular formula, the name, by the way, is propene. So the name is propene. Then the molecular formula, you just put a 3 here. So it's going to be C3. Then you put a 3 here, which is 3 multiplied by 2, going to be HH6. Then the structure formula now, in terms of structure, how many carbons are they? 3 carbons. But remember, between 2 carbons, there should be a double bond. It doesn't necessarily matter where it's supposed to be. Unless you are given the name, then now you can be specific where to put the double bond. So we can start it like this, 3 carbons. So the double bond can be here, the name will still be the same. Where if you put a double bond here, which means this one only 2 bonds are remaining, but this one in the middle is already bonded to 1 and 3, okay, because that double bond are 2 bonds, so already bonded to 3, so you just need 1 hydrogen on top. Then this one is bonded to 1, so you need 3 hydrogens. So make sure that each carbon does not get beyond or is not bonded to more than 4. For example, if we were to put hydrogen here, this will be wrong because this hydrogen is already, this carbon has been now bonded to 5, which is not true for carbon. So this is propene. But if you want the double bond can be here, which means this one is going to carry something like this, then this one will be like this. I guess you've gotten a thing here. Okay, so the bond can move. As we look at isomers, you understand better. Okay, I guess there's no problem up to this point. So we've gone up to the second one. So this is the second one. So if they ask you about the second member in the series is propene and not ethene. There's no one with 1 carbon. Let us look at the one with 4 carbon. So 4 carbon, we put carbon there, carbon there. We are going to have C4H8. The structure, we draw 4 carbons, we put up 4 carbons. At least between a carbon, there should be a double bond. So if we are to choose to put the double bond there, which means these others will just be bonded like that. This just need 1. This needs 2 up like this. So this is butene. Okay, the name is butene. So that is how it can be drawn. But the double bond can shift. It can be here. So the thing that you need to know, at least between 2 carbon, there should be a what? A double bond. So go on and draw up to 5. So up to 5, which means you are going to go for the one with carbon 5 and the one with carbon 6. Okay, remember when you are counting, the first one in the series is ethene. The second one is propene. The third one is what? Butene. The fifth one is pentene. So if they ask you draw the structure of the third member in alkenes family, is butene and not propene, like the way it is in the case of alkanes. I guess my point, I've emphasized on this point for some time now. I guess you've gotten a point. I know how confusing it can be. All right, let us move to isomers of alkenes. Isomers of alkenes. So isomers or an isomer is still defined the same. Compounds having same molecular formula but different what? Structural formula. So also alkenes exhibit isomerism. Alkenes also exhibit what? Exhibit isomerism. Okay? Now, there are 2 types of isomers that we can look at in alkenes. So we can say isomers. Okay? So there are 2 types of isomers under this one. 2 types of isomers. So one is called the branched, where you have a branch. Then the other one, we talk of positional what? Isomers. Now, when you talk of positional isomer, we are just looking at the position of the double bond. Okay, the position of the double bond. So we are going to begin with the positional isomers and just look at where the double bond is. So we begin to this one. So positional isomers. Let us say, for example, so also this just like alkenes with 4 carbons and above exhibit isomerism. So how is it? So for example, let me give this butene. So the first one that we are going to use is butene. Butene in terms of structure is drawn like this. So I'll start by putting up the double bond between, drawn like this. So this is hydrogen, 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 hydrogen there, hydrogen there, and hydrogen. So this is butene, okay? Of course, there's hydrogen that is needed there. This is called what? Butene. Now, if we are to name this one, following the double bond, where the double bond is, under this one, we prioritize the double bond, which means where we are coming from, we're saying, okay, where the branch is, you give the lower number. But under this one, we look at where the double bond is. But we count going forward, backward. So 1, 2, 3, 4. If we are to count backward, 1, 2, 3, 4. Now look at this. Counting forward, the double bond is at carbon 1. So the double bond is at carbon 1 here. But counting backward, the double bond is at carbon 3. We are coming back. So the number before the double bond is the position of a double bond. So here, the double bond is at carbon 3. So which one is the lower number? We want to give it the lower number. So the lower number here is 1. So therefore, we are going to follow the forward counting. And of course, put the double bond at what? Carbon 1. Now, how do you write these isomers? We know that this is butene, and the prefix for butene is but. So but, then we put a dash, the position of the double bond 1, then we write ine. So this is how but1-ine is written. I guess you've gotten that. So for this, you look at where the position of the double bond is. Then now the prefix is but for 4 carbons, 1, that is dash 1, then family ine. That is how you write it. Let us say we shift the double bond now. So that was the first one. We shift the double bond to here. Here, which means there's no double bond. The counting is the same, going forward, backward. So this is 3, this is 4. Now, going forward, the double bond will be at carbon 2. We said the number behind the double bond is the position. So the double bond will be at carbon 2. Even backward, the double bond will be at what? At carbon 2. So either way, the double bond is at what? Carbon 2. Okay? So in this case, we are going to put, but dash 2 ine. Okay? So that is the name. So but dash 1 or but dash 2 ine, that is the name. Okay, I guess we are together up to this point. We've not lost anyone. I guess we are moving together. Let us look at another example. This time around, we try to put the branch. Okay, so this same one, butene. Okay, butene. We try to put a branch this time around. Let us say the branch is here. Okay, so we draw it like this. This is still, let me just draw the straight one like this here. Okay, like this, like this. So this is called but. This is but dash 1 ine. This is but 1 dash ine. Then what about this? What is it going to, what do we call, or what are we going to call it? So here, the first part, let me put a double bond there. Okay, which means here. Then this one is going to be, so please, this one on top was not supposed to be there. So it's just going to be like this. I guess I've drawn it right. Okay, so now we have such a situation. What do we do? So either way, we count. So the long chain is this one. 1, 2, 3. Backward, 1, 2, 3. Okay, then the branch is at what? The branch is right here. Okay, so what is the name of the branch? So now here, before we go to the name of the branch, look at this. When there was only the branch, we prioritize the branch, which means we consider the branch twice. But where there's a functional group, and the branch, you consider the functional group first. So you give the lower number to the functional group. When you do that, whatever remains goes for the branch. So going forward, the branch, the double bond is at carbon 2. The double bond is at carbon 2. But going backward, the double bond is at carbon 1. So that is where the double bond is. So you're going to consider the one that gives us a lower number. And therefore the branch is at carbon what? Carbon 1. Pay attention. But the name of the branch, the name of the branch is methyl, and the branch is at carbon 2. So we write the first number is for the branch. Okay, 2 dash, what is the name of the branch? Methyl. Then 3 carbon alkene is called propene. But of course, we are going to write prop dash, the branch is at, the double bond is at 1. Then we write ine. Otherwise, this is the name. 2-methyl prop dash 1 ine. I guess you've gotten a thing up to this point. Okay. So the other thing that we can look at now are the chemical properties of alkenes. What are the chemical properties of alkenes? How they react. Chemical properties of alkenes. So for alkenes, they are reactive. Okay? Alkenes are what? Are reactive. They undergo certain type of reactions. So we can say alkenes are reactive. Why do you think alkenes are reactive? Because of the double bond that can break to form a single bond and add atom or add other atoms. Okay, so because they are reactive because of the double bond, that can break and add atoms so because of the double bond that can break to form single bonds and add other atoms. This is the reason why it is reactive. Now, types of reaction that it also undergo what we call combustion reaction. So this one we might not spend much of the time because we've looked at combustion reaction. So undergo combustion reaction, and we know combustion is just burning in presence of oxygen. And in this case, still we discussed two types of combustion. So combustion, we've discussed it already, but of course we look at two types of combustion where we look at what? Complete combustion. And we know that complete combustion occurs in abundance oxygen or plenty supply or full supply of oxygen. So under this one, we can say that alkenes also burn or undergo complete combustion to form carbon dioxide and water. So in both cases of combustion of organic compounds, carbon dioxide and water is formed in the complete combustion. So in this case, we can give an example of the first member, which is an ethene. In this case, it burns in the presence of what? Oxygen. What is produced is, since we are talking of complete combustion, is carbon dioxide and what? And water. Make sure that you balance the equation. So to balance this one, we just add a 2 there. We add a 2 there. We add a 3 there. We should be able to, or this is the balance equation. Make sure that you check it out. They can also burn in less supply of oxygen or limited supply of oxygen. And you know what is produced? What is produced is the carbon monoxide and water. Okay? So alkenes can also burn in less supply or limited supply of oxygen, producing what? Producing carbon monoxide and water. So make sure that you are aware of that. Okay. The other type of reaction they undergo is called additional reaction. Additional what? Additional reaction. That is across the double bond. So addition reaction across the double bond. Now, what about addition reaction across the double bond? So you're saying since alkenes, we know that alkenes, are unsaturated hydrocarbons, and this is because this is because of a double bond. Okay, they are unsaturated hydrocarbon. Okay, and therefore they undergo that is additional reaction across the double bond. You know the double bond can break, forming single bonds, which leave room for other atoms to attach, and this is the reason why other atoms can attach. So without wasting time, let us look at the types of additional reaction. So the main thing here, or the main reaction, is additional reaction. Why they undergo additional reaction? Because they have a double bond that can break, forming single bonds that can attach other atoms. So very important to understand that. So the first type of additional reaction that these undergo is called hydrogenation. Now, hydrogenation, in other words, is just the addition of what? Of hydrogen. And where we are coming from the molecular formula, molecular formula, we know that, or the general formula, we know that alkenes, they lack 2 hydrogen compared to alkenes or alkanes. Okay? So, hydrogenation, just addition of what? Hydrogen to alkenes. Okay? Addition of what? Hydrogen to alkenes. To form what? To form alkanes. So one way alkanes can be made is by hydrogenation of alkenes. I hope you've gotten that. Okay? I hope you've gotten that. Now, this one occurs in, so here if we look at condition for hydrogenation, condition, it occurs in presence of a what? A catalyst. So very important to understand the condition. So occur in presence of a catalyst. And what is a catalyst in this case? Nickel act as what? A catalyst. Aside from nickel, the other condition is the temperature. Okay? Temperature of around 300 degrees Celsius. So very important to understand this. So additional reaction under alkanes, that is additional reaction across the double bond under alkenes. One of the additional reaction is hydrogenation, where hydrogen, or there's an addition of hydrogen to alkene to form alkanes. The conditions for this is the catalyst, nickel, and temperature of 300 degrees Celsius. Example, if you have the simplest alkene, which is the ethene, this, then react with what? Hydrogen, presented like this, in the presence of what? Nickel, then temperature of 300 degrees Celsius. What you form is an alkane. So the double bond break, and of course other atoms attach. So we are going to picture more like, let me just put a different color. So the hydrogen, when the double bond break, the hydrogen that come from this, so hydrogen attaches like this. So we have an addition of 2 hydrogens. So that is how you can look at it. I guess there's no problem up to this particular point. So that is one of the reaction that it undergo. Then the other additional reaction is called hydration. Hydration. So hydration is just addition of water, okay, and resulting to formation of alcohol. So alkenes can undergo addition reaction to form what? Addition reaction of water to form alcohol, okay, to form alcohol. So the catalyst in this case, so we're saying addition reaction, so alkenes undergo hydration reaction to form alcohol, okay, to form alcohol. Then conditions, what is needed for this reaction? One, catalyst, which is what is a catalyst here? Phosphoric acid is needed as a catalyst. Okay, so in some cases you find steam. So hydration, addition of water, or steam, just the same. Okay, so example of the simple alkene, which is we'll keep using this. Plus, so what is going to happen? What is going to happen is, so here we are saying in the presence of what? A catalyst, which is the phosphoric acid, temperature of around 300 degrees Celsius as well. Then of course, pressure of around 60 atm. 60 atm. So conditions, we have a catalyst, then pressure 60 atm, then we have temperature 300 degree Celsius. So these are the conditions for this one. Then what is going to form here is this. So here, let me just put a different color. So we are going to have hydrogen attached to that, then that. So this is alcohol, which is what? Ethanol. This is the ethene. This is the steam. Then the conditions. Okay. So that is how you can look at it. That is how you can look at it. Okay, so the next part we are going to continue with other reactions that alkenes undergo. For a moment, we can end here. And please make sure that you go through the past papers. Make sure that you go through the question papers. Make sure that you go through as many question papers as you can. Otherwise, we can end here. If you are interested in the online lessons, you are interested to join us for physical lessons, you can contact the number 0976 402 563.